Welcome to homework.
For this problem on the topic of atoms, we are told that X-rays shown in the figure are produced when 35 keV electrons strike a silver target. We want to find the values for the minimum wavelength lambda min, the wavelength of the K alpha line, and the wavelength of the K beta line. We are given the K, L, and M atomic X-ray levels for silver to be 25.51, 3.56, and 0.53 keV respectively. Now the X-rays are produced when a solid target, which in this case is silver, is bombarded with electrons whose kinetic energies are in the keV range. The wavelength lambda min is equal to hc over k naught, where k naught is the initial kinetic energy of the incident electron. Now we know hc to be 1240 electron volt nanometers. So the minimum wavelength lambda min, which is hc over k naught, is 1240 electron volt nanometers divided by the initial kinetic energy, 35 times 10 to the 3 electron volts, which gives a wavelength of 3.54 times 10 to the minus 2 nanometers, which is 35.4 picometers. Next, for part B, we know a K alpha photon results when an electron in a target atom jumps from the L shell to the K shell. The energy of this photon is E, and this is 25.51 keV minus 3.56 keV, which is 21.95 keV. And its wavelength, lambda K alpha, is equal to hc over E, which is 1240 electron volt nanometers divided by 21.95 keV, which gives us the K alpha wavelength to be 56.5 picometers. For part C, we want to find the K beta wavelength. We know a K beta photon results when an electron in a target atom jumps from the M shell to the K shell. And so the energy of this photon is 25.51 keV minus 0.53 keV, which gives us 24.98 keV. And so the associated wavelength, lambda K beta, is equal to hc 1240 electron volt nanometers divided by this energy, 24.98 times 10 to the 3 electron volts. This gives a wavelength of 49.6 picometers.